how do we come to be? Every civilization has wondered this, but today, science tells us that humans are a single branch in the tree of evolution, with all organisms originating from one singular cell. But how did this cell come to be? Today, we will be looking at the theory of abiogenesis, how it relates to extraterrestrial life, and why we don't see aliens. Now, what even is abiogenesis? Well, it's the development of life from chemical reactions. Complex life, as we know it, could not realistically assemble from a mixture of molecules in the oceans. So the first organisms would have had to have been very simple. I'm talking simpler than a single cell. Now, life would have started out off as basic self-replicating chemical reactions, and the reactions in some molecules would have been more efficient than the reactions in other molecules. And the more stable a self-replicating molecule, the more it'd be able to reproduce. And if a self-replicating molecule was not stable, it would eventually die out and no longer reproduce. And what this tells us is that Darwin's theory of natural selection also applies to self-replicating chemical systems, not solely biological systems. And these self-replicating chemical systems could have eventually evolved into life to make the self-replication process more stable. But could this even happen? Well, the RNA world hypothesis theorizes that RNA was the first organic molecule and that it was capable of self-replication. Today, all organisms, and even non-organisms such as viruses, use RNA for gene replication or storage of genetic info. And this reliance on RNA shows that it stems far back all the way to the first organisms. As stated in the research article, Highly Efficient Self-Replicating RNA Enzymes, hosted by the National Library of Medicine, Robertson and Joyce state, an RNA enzyme has been developed that catalyzes the joining of oligonucleotide substrates to form additional copies of itself, undergoing self-replication with exponential growth. Now you might be wondering, what does that mean? Well, it just means that a self-replicating RNA molecule is possible. And as you may remember from biology class, which, no hate if you don't, different bases on RNA molecules causes different reactions to occur. And as I said earlier, the Darwinian natural selection process could select for bases that produced RNA molecules that had features that would allow them to self-replicate better. One of these features could possibly be a cell membrane, as this would make the self-replication process more stable, and this would also lead to the first cells. Now, what's the likelihood that these processes could take place on other planets? Well, as stated in Big Things 2022 article, How Many Planets Are There in the Universe? Ethan Siegel calculated that in the observable universe, there are around 10 to the 25 planets that orbit stars, or this big number, and there are, with some, around 10 to the 26 to around 10 to the 30th additional starless planets, or these big numbers. Now, we all know that life needs energy to survive, and in Steve Cobb's 2022 article, The Origin of Life on Earth Explained, hosted by UChicago News, he states, in reference to hydrothermal vents, these chimney-like vents, form where seawater comes into contact with magma on the ocean floor, resulting in streams of superheated plumes. The microorganisms that live near such plumes have led some scientists to suggest them as the birthplaces of Earth's first life forms. Now, since we know that organisms can survive in the bottom of the oceans with no access to sunlight, purely surviving off the energy from hydrothermal vents, we can get from this that life could also arise on other planets surviving purely off the energy from the hydrothermal vents. And this allows us to include the number of starless planets in these following calculations. Now suppose that Earth is 1 in a million. This would mean that around 10 to the 20th planets would develop life. Okay, now what if Earth was 1 in a billion? Still, around 10 to the 17th planets would develop life. Now, let's just say, what if Earth was 1 in 1,000 trillion? Still, around 10 to the 11th planets would develop life. And we have only observed around 6,000 planets. And there may even be life on those planets that we just haven't detected yet. Now, if there's so many opportunities for life to arise, why haven't we seen any aliens? Well, the Fermi paradox asks this exact question. And there are a few solutions to the Fermi paradox. The two that we're going to talk about today are the Great Filter and the Dark Forest. Now, the Great Filter states that since we don't see aliens traveling through space, there must be something stopping organisms from reaching that spacefaring level. And there are many possible obstacles, some of which we may have already passed, such as abiogenesis, evolution into multicellular organisms, and even formation of civilizations. But they could also be ahead of us, obstacles that we need to pass if we want to go on and colonize the universe, such as surviving nuclear war, surviving asteroid impacts, or surviving disease. Now, if we are past the Great Filter, as I said, we are likely to go on and colonize the universe. But if we haven't passed it yet, we are either to likely die before leaving the solar system, or we will live, but we will never leave the solar system. Reassuringly, in his 2020 article, The Great Filter, A Possible Solution to the Fermi Paradox, hosted by Astronomy.com, Doug Adler states, on the bright side, some have interpreted our apparent aloneness in the universe as a good sign, a blessing even, as it indicates we've safely made it through the bottleneck. Strange as it may seem, we may be the first species to have passed through the Great Filter. Now, another more grim solution to the Fermi paradox is the Dark Forest. And it relates the universe to a dark forest filled with hunters, in which each hunter stays quiet and immediately shoots upon hearing another hunter as to protect themselves. Now, this could explain why we don't see any aliens, as they may all just be hiding, not wanting to broadcast out any signals that they are there to allow another alien civilization to come and annihilate them. Now, this begs the question, should we stop broadcasting radio signals out into space, as this could be alerting other alien civilizations as to where we are and that we even exist? Now, today, we have discussed how abiogenesis could explain the possibility of aliens. We have also discussed how the Fermi paradox explains our lack of evidence for aliens. Now, this just leaves us with some questions to ask ourselves. Will aliens hear our radio signals and come to annihilate us? Is our destruction inevitable? Are we completely alone in the universe? I wish you all the best of existential crises.